Alright, so we're writing straight in our journal today. I'm going to try to keep this under 15, but it's going to be pushing it, so I'm not going to waste my time and talk too slow. Back up and rewatch anything that you need to back up and rewatch. We are going to be finding inverse functions algebraically. Okay, so when you talk about inverse functions, it has different notation. The inverse of a function, whatever it happens to be, I'm going to use f of x, that's our most common number or name that we go to. The inverse of a function, f of x, has a different kind of notation. It looks like this. It looks just like that regular function notation, but I have a -1 up top to tell me that that is an inverse. And you read that by saying f inverse of x. That's how you say it. Okay, so I'm going to give you the steps. I'm only going to do 3 examples with you, and then we'll do some work in class, but I want you to just get the steps down and know what we're doing. So here we go. The first thing you're going to do is you're going to replace the f of x with the letter y. Okay? Not complicated. And then you're going to switch the x and the y. So I think it would benefit you if I do the example as I give the steps. And so let me go ahead and leave me some room for this. We're going to have 5 little quick steps, and here's my first example. I want to find the inverse of this function. F of x is equal to -5x plus 2. So I'm going to switch the f of x to a y. I'm going to kind of highlight what I'm doing here with a different color. So that's -5x plus 2. I hope that color shows up well, maybe so. And then I'm going to switch the x and the y, so that's going to be x here and y here. So x equals -5y plus 2. And I'm going to just solve it for y. So let's do these inverse operations. That's my third step, is to use inverse operations to solve for y. And that's not any, I don't mean that to be anything complicated or confusing or try to make it sound super technical, but when I say to use inverse operations, that means undo what's being done. So when I write the plus 2 over here, I'm trying to get the y by itself. Let's subtract 2 from both sides. And so I have x minus 2 is equal to -5y. And then I've got to get rid of the multiplying by -5y, and the inverse of multiplying is dividing. So I'm going to divide by -5. And I get this, x minus 2 over -5 is equal to y. Well, I just solved it for y. Let me scoot up, sorry. So I've solved it. Now, you want to turn it around so that the variable is on the left, because that's just how we, or so that the y is on the left, because that's just how we write a function. So I can say right here, you're going to replace that y with that inverse notation and rewrite it as the inverse of the function equals, and then you just put in what you got to put in. So I'm going to do that. That becomes f inverse of x, and it's going to be equal to x minus 2 over -5. That's not the only way to write that, and I want you to recognize that because you will see it in other formats. You can, if you've got a fraction and there's adding or subtracting in the numerator, not the denominator, you can do this. That's an understood one. So that would be a negative 1/5 x plus 2/5. Sorry, that's kind of sloppy. Because negative 2 over negative 5 is a positive 2/5. That's a linear function. And so we have to verify, last thing, verify that the inverse is 1-to-1 or a function. Make sure that it passes that vertical line test. Okay? So let me just give you a little bit of, right here in this little section, I'm going to throw in some bonus information free of charge just today. So here's how you do that. It's really simple. Verify that you have a function. First of all, if it's linear, that would be anything that looks like this, or y equals mx plus b. If it's linear, it's a function. You don't have to worry about any restrictions on the domain. It just is a function. If it's quadratic, or quartic, or anything with an even exponent, second, fourth, sixth, eighth, whatever the degree is, anything that's got an even exponent, that's where you got to find those domain restrictions. And typically, I'm going to show you how to do this in just a second, but the easy, quick way to do it would be to use your table on your calculator. If you don't remember that from the 9th and the 10th grade, on your calculator, let me get there, you can press that table button right here, and we'll put our function in, and I'll show you how to find the domain restrictions for your inverse function. Okay, and then the last part is if you have a cubic or anything with an odd exponent besides 1. Because that's linear. If you have a cubic or a 5th power or a 7th power or whatever, they typically are 1-to-1. Because if you remember what a cubic function looks like, it's like that. And so if I reflect it over that line, y equals x, it's still going to be a function. This is terrible. I'm horrible at drawing this, but let's just say here's my line. If I reflect it over that, that's terrible. It's going to look like this. I did that, like I exaggerated that a little bit more than it should have because it would still be a function. But sometimes you do have to find those domain restrictions on the cubics, but not. We're going to get into anything complicated with that. Here's really what you're going to have to look at is the quadratic stuff. So let's flip over to the back of this page and do 2 more examples, and then we'll finish up stuff in class. So example 2. I want to find the inverse of f of x equals 2x squared plus 2. And if you remember that big long pile of explaining I did in class where half of you looked at me like I was speaking some kind of crazy language, this domain restriction is just for this purpose. If I were to graph this, and I'm not going to drag out my graphing calculator and make you suffer through that again, but if I were to graph it, it would look like this. And when I reflect it across that line, if I reflect this over that line of reflection, that y equals x, I'm not going to have a function. I'm going to have something that looks like this. And so this domain restriction cuts off this part of the original function which means it's going to cut off this part of the inverse, and that's what gives me my function right here. So when we do this one, we got to figure out what that's going to look like. Okay, so my inverse is going to look like this. I'm going to replace this with a y. I don't even need this part anymore. This is just to let me know that, hey, I'm only graphing this half. Okay, and then I'm going to switch these two. And I'm going to solve for y. So I've got to start these inverse operations. I've got to start undoing the things that are being done to the y. So I'm going to subtract the 2. And I'll have x minus 2 equals 2y squared. I'm going to get rid of that multiplying by 2 by dividing out the 2. And I'm going to have this. X minus 2 over 2 equals y squared. I don't even know if y'all can read that yellow, so let me go back and do it in maybe pink and see if that shows up a little bit better. Okay, now the opposite of squaring the y would be to take the square root. So when I take the square root of both sides, I'm going to have this. If you don't mind, I'm going to go ahead and switch this over here because that's going to get rid of that. And so I get y equals the square root of x minus 2 over 2. Now here's where I need to check for those restrictions on my domain. If you will go to your table and let's type that in. That was magic because I already had it. Haha. Anyway, so let me get out of there. So hit your fraction button. Just kidding. Do your square root. Hit the fraction. We're going to do x minus 2 over 2. I want to start at 0. And I'm going to just keep pressing enter until I get my table. And so what I'm looking for is where does this thing start having values for x and y. And it starts where x is 2. Where x is 2, y is 0. And then it keeps going up from, well, actually my numbers are, going up slowly, but they're getting bigger. My y values are getting bigger. And so what I need is to go back and say, okay, this is where it starts, right there. And so my x values start at 2, and my x values keep getting bigger as my function grows. And so my restrictions here would be that x is greater than or equal to 2, because that's where it started. So now I need to do my function notation. I almost forgot that. So change this to my function notation. The f inverse of x is equal to the square root of x minus 2 over 2, and x has to be greater than or equal to 2. And there's my final answer. And I'm going to see if I can squeeze in one more little tiny example at the bottom, and I think I can. Okay, so let's look at example 3. I want to find the inverse of f of x is equal to 12x to the 5th. Okay, so we are going to replace that with a y. Switch the x and y. And let's start doing these operations to get this y by itself. So I need to divide by 12. And so x over 12 is equal to y, to the 5th. That's a y. That looks terrible because I started writing a 5. And then the way you get rid of raising something to a power is to take that same root. If it's to the 10th power, take the 10th root. If it's to the 3rd power, take the 3rd root. If it's to the 5th power, take the 5th root. And you're going to do that on both sides. And so I've got that's going to undo that. I'm going to go ahead and bring my y over. And that gives me the 5th root of x over 12. And since that was raised to an odd power, if I were to graph that, it's going to be one that looks like this. And so when I reflect it, I'm still going to have a function. And so I have no restrictions on this. And my final answer, changing that to my inverse notation, is going to look like that. And so I'm going to show you real quick. I don't know how this is going to do in this calculator just because of that being the fifth root, but I'm going to take it out and let's see. I don't even know if, there we go. So if you don't know how to do this part, you're going to hit 5 and then hit second and this button. Let me get up where you can see that. This one, see where it's got the x outside of the radical? It's going to do that. Hit the fraction button, x over 12. And it doesn't really matter where we start at because this is a continuous function. And I have no restrictions because I have answers for everything. Okay? So, that's my answer. So, we'll do some of these in class. And that's the end of that.
Can I please have your attention, please?